Okay, we're back, and again, if you just keep videos off and all that good stuff. And if you do have questions, feel free to type it. If you want to type privately, again will try to type it back to you and see that private. Or if you have questions, again, you can type it to everybody, and I'll just answer over the thing. Again, if you have questions on anything, feel free to ask. I could try to work things out on the screen for you if you need, or just want to hang out and work on some stuff and then ask questions, feel free. So again, a reminder, if you do have questions, feel free to type them. And a reminder as well, like I said, towards the end, their lecture, um, your lab instructor did send out an announcement about the new video, I think for the experiment this week that's been posted. So if you haven't already done so, make sure that you do check it out, and make sure you follow her instructions on how to submit those to her. Again, send those to her, not me. Okay, let me answer, I guess, one question at a time, I guess. What was your question about the exam? Maybe while you type that, I'll answer the other question that's there. What cases do we use M1V1? So the M1V1 the M1V1 equals M2V2 is really used for dilutions. And again, that is when you take basically a solution that's more concentrated and basically take a little bit of that solution out and put it into a new container. And then add something like water to it. And basically when you do that, that's going to give you a diluted solution. So it's like those last sort of calculations we were doing. Is when you basically have the same thing, but the only difference that you mainly see is the molarity value. So for example, the first one we did, there was like 19 molar. So basically we're diluted and the molarity goes down. So I get it more constant. So the molarity, and that is, and again, on both sides. So again, in places like equals so written like that, and that's also the dilution equation. So as I mentioned in the lecture, even though most of the time we use molarity, you don't have to necessarily use molarity here, and that's what the C stands for. It's just generic concentration. So you could use something like those percent mass to mass, for example, percent volume to volume. But most of the time when you do a dilution, it's usually the M1V1 equals M2V2. And we usually use this one because, like I said before, basically molarity is the sort of most common unit of concentration. Questions on that? Yeah, so the question on the exam is, I think you guys talked me into it, so we're going to probably move the exam to Monday the 13th. I'll put an official announcement out probably like this Wednesday and stuff, as soon as I double check everything on the schedule, but probably 99% sure we'll probably move it to that Monday the 13th. Again, it should cover, I think, chapters 5, 6, and 7. So since we completed the chapter 7 today, that's pretty much everything that will be on the exam that's coming up. So I think it is going to probably be pushed down Monday, which I'll trust you guys. You said it was the 13th. Sounds good to me. We'll go with the 13th. So remember, did I get your question on the exam? And did I get your question on the dilution? Everything good on those? Yeah. Okay, so another question is sort of, how do you determine a solution, a colloid, or a suspension? So as we were talking about towards the end there, basically a solution is, something that's aqueous. So it's got the solute and your solvent together. And usually, for example, if you take like a filter, a funnel and a filter paper, and you pour a solution through, it typically will, right, go through the funnel, right? A solution, for example. So a solution pretty much can go through usually a filter. It could also usually go through a membrane because, it's small enough to kind of do that. When we talk about something that's a colloid, those are usually a little bit larger groups, like proteins, for example. And those also, as we saw, I think in that last slide, these little triangles have the ability to kind of, when it comes to like suspension, I mean, these so when when you're thinking about sort of those different things, for example, you want to think about, something that it's a bad type of bag, would it be able to get it out of the problem, and would you basically as so the answer is yes, both those, like memory, maybe remember, if it's something that will filter paper, but still trapped by the filter, but too large back, then you're like, and that's some ridiculous things to get stuck. The experiment you would have done for just come in my video, part of the video. I think sand or charcoal is I can experiment, and again right source out charcoal, then you start on the filter through the suspension. So some of the any solution, whatever. That way, it's to figure out so if they sort of that problem with that solution, if it wasn't and anything that obviously remained in the bag would be a suspension, and those larger things that are homogeneous, that looks uniform, would be a colloid. So for example, apple juice would probably be a solution, right? If you put that through a filter, it would go through. And if you put it like in a dialysis bag, it probably would be able to work its way out and stuff like that. As opposed to hand cream, if you slapped hand cream, like say in a filter, probably not going to go through, right? If you did that, and probably wouldn't. It wouldn't make its way out. I would say Gatorade probably would be a solution, right? So solutions, kind of any drinks or stuff like that would probably be a solution, right? Because remember, basically what makes a solution, right? If you sort of help you out with that, is this idea. Really, it's basically something like this in a water environment. So if you think about something that's sort of aqueous, you think about it sort of, I don't want to say exactly like water, but maybe flows like a water or a liquid beverage, sort of like that, is sort of how you would think about it. Yeah. So something like I'm sorry. So the hand cream, the hand cream, for example, the hand cream might not go through the filter, for example, but if you did sort of put sort of hand cream like in a dialysis bag in sort of a solution, right? It probably would, some of it would go through. So you could kind of think of it like when you have sort of watery hand cream or something like that, or lotion, right? When it gets into the water, it's able to sort of thin out a little bit. So it probably would perhaps be able, some of it to pass through. Is probably a more of a homogeneous type mixture. So I probably would go maybe with a colloid on that, because it will look kind of the same throughout. If you look at like hand cream, right, it just looks sort of the same. It's all white, right, or whatever color your hand cream may be. So like a white cream or something like that, for example. And that's probably the main difference that would leaning towards a colloid versus a suspension. Again, a suspension is a heterogeneous type of mixture. So usually, unless you have lumpy hand cream, I suppose, you don't have too much stuff in it. So it would look more as the same throughout. So probably more towards a colloid for that. It's been a while since I thought about hand cream and what it would be, but I'm assuming that's on your lab, I guess. Yeah. work. Okay. Which is why I like something perhaps like sand would sort of be considered a suspension. Again, when you look at something like sand, it maybe doesn't look the same throughout. Sometimes it'll have stuff in it, and you'll see sort of different things in it, and it'll be more like a heterogeneous one. So when you have to choose between those two, that's sort of the other sort of defining difference between colloid and suspension. One is more homogeneous, so everything should kind of be the same throughout, or appear sort of the same. And the heterogeneous, again, you'll see sort of different layers, if you will. So the question about which pair of compounds would form a solution, I'm assuming that would probably be related to like those solubility rules, for example. So I think we talked about solubility rules in this chapter, chapter 7. So for example, things like in group 1 are always soluble, which means that they would get that aqueous symbol and be a solution. Things that have ammonium, um, things like nitrate is also soluble in everything. So you might want to look at that. In terms of that. So again, if something is listed on that solubility sort of table as being insoluble, those guys will make a solid and not a solution. So they'll get that S symbol next to it versus the aqueous symbol. Things like, for example, chloride, bromide, and iodide, they're soluble in everything except, for example, silver, lead, and mercury. So if you had any of these guys in a formula, you would expect it to be soluble, except if you had one of these guys in there with it. Because sodium's group 1, and chlorine to make in this aqueous. So you would get a solid, and it wouldn't be obviously a solution in that case. So you might want to refer to, I think there's I think in the notes, but also I think in the chapter there should be like a solubility table. if you're good, I'm good. Thanks for coming by. If you have questions, feel free to stay and ask. Otherwise, have a good night, and I'll see you Wednesday. Okay, if there's no other questions, I'm going to end this meeting. Have a good night, and we'll see you on Wednesday.